Hey, hello everyone. So today we are going to discuss something about differentiation, and that too in the easiest possible way. So let's get started. Let's start with an example, shall we? Here I have a graph of y is equal to x squared, and pretty simple. I want to take out the slope of this graph. What is the slope? The slope is the steepness of the graph, and we calculate it with the formula y2 minus y1 upon x2 minus x1. I hope you guys know this. High school. So, yeah, I need to take out the slope of this graph. The only problem is that this is not a straight line graph. If it would have been a straight line graph, I would have just taken out the difference in y and divided by the difference in x. The thing is that this is not a straight line graph, this is a curved graph. Okay, never mind. So, I hope you guys know that if we have 2 points, we can easily construct a line passing through those 2 points. So what if I construct a point here and another point here, and then I join those points? We get a straight line, and now we can take out the slope of this line, right? The problem is that this will just be an approximation of the exact slope of the graph. Why? Because there's a deviation in the graph. As you can see, this deviation in the graph from a straight line. So what we do is we draw this point a bit closer to the original point, and then we draw our straight line, and that's already much better. That is a much better approximation, as our curved line is lying almost on the straight line, but still it's not the exact approximation. So let's draw that point a bit closer, and now we get the line. Oops. Now we get the line, and that's pretty close. That's almost the line we're looking for. You know what? The more the better. Let's just keep doing it. Let me. Yep. Yeah. And oops. Let's draw a line there. And yeah, that looks like a pretty good line. And if we take out the slope here, what we're gonna get? We're gonna get a line passing through those 2 points, and that line would be this, and that line would be the slope of this graph at this particular point. And that line is called the tangent. So, what is the slope of a graph? The slope of a graph at a point is the tangent to the graph at that point. So, how are we going to how are we going to calculate this tangent? So, what we're going to do is we're going to take an arbitrary point, the point at which we want to take the slope of the graph. So, suppose I want to take the slope of the graph at x is equal to 1, right here. That is my point, and I want to take out the tangent to that point. The thing is that I don't know how should I make the line, because I need 2 points to make a line, and I only have 1. But also, I don't want to travel further away from the point, because if I travel further away from the point, my approximation would get less accurate every time. The thing is that I would take a point which is almost the point that I marked, which means that I'll take a point which is very, very close to this point. So suppose that this our point which we have taken to be very close is this. Just suppose it's not very close, but still, let's suppose. So this is the coordinate of this is something like x comma y. Let's turn down the thickness. Yeah, so this is something x comma y, and this distance that we have traveled between the point, let's just call it so this is x comma y, and let's call this distance some h. And remember, this distance h is very small because we want this distance to be as small as it can get. So this point is as near to this point as possible. So this h is very small, but still it is there. So this is our x, this is h. So this point would just be x plus h, y, and this point would be what would this be? This would be x plus h, comma y plus h. Now we can easily take out the slope of the line. How we can take out the slope of the line? Well, we can do our formula y2 minus y1 upon x2 minus x1, which is just y2 is y plus h, minus y1, which is y, x2, which is x plus h, and x1, which is x. And these cancel out, and we are left with h divided by h. Will this be equal to 1? No, it will not be equal to 1. Then why are we getting such an answer? It's because this h is a quantity so small, it's unimaginable. Yes. So we cannot cancel this out because this is almost 0, and 0 divided by 0 is not equal to 1. So how are we going to tackle this? Well, let's do something like this. Let's take our point, and then this point, this is x comma y, this is x plus h comma y plus h. And now what we're going to do is we're going to make use of our function. Our function is y is equal to x squared. So what we're going to do is the slope for this graph should be y2 minus y1 upon x2 minus x1. And what is y? Y is just x squared. I mean, that's what we just saw. Y is x squared. So what if I replace this y with x squared here? So let's do that. X2 squared minus x1 squared. That divided by x2 minus x1. Let's try it now. So what is our x2 squared? What is our x2? x2 is x plus h. So x plus h whole squared minus, which is our x1? It's just x squared. And x2 minus x1, it's just x plus h minus x. So it's just h divided by h. Let's try to solve this. X plus h whole squared, x squared, plus h squared plus 2hx minus x squared divided by h. And now these terms cancel out. What we are left with is h squared plus 2hx divided by h. We can take h out of this expression. So h into h plus 2x divided by h. And now we can cancel these h out as long as it's not 0. What we're left with is 2x plus h. And remember that h is an unimaginable quantity. It's as small as it can get. So h does not, we do not consider h because it's very small, right? It's as small as it can get. So it makes no difference if we include h or not. So 2x plus h is same as 2x because h is just, it's a negligible quantity. So what we are getting? We're getting 2x, which is, what does that mean? It means that the slope at this curve, at this point of the curve, is nothing but 2x. And like that, we can take out the slope of any point on this curve. So what we just took out means, it means that if I take out a point here, this point is 1, 1, and I want the slope at this point. What is the slope at this point? So what is the x position? The x position is 1, right? So the slope would be just 2 into x position, which is 1, is equal to 2. So the slope at this point, at this exact point, will be 2. Oops. 2. And that slope is called the derivative. And there we go. That is differentiation, the easiest approach. Like that, you can take out the derivatives of different functions. Just try x cubed by yourself. It's easy. Just follow the same method. Just plug the function in place of y, solve it, cancel h at the end, and then get your answer. See ya.